Thanks for coming back. We've got one more example to go through, and then you can be on your way. So for this last example, we are expanding 3x squared minus 8, that's the binomial, to the fifth power. Now, since it's to the fifth power, we're going to be using the fifth row of Pascal's triangle. So I'm just going to write that fifth row here. We have 1, 5, 10, and then it goes the other way, 10, 5, and 1. So I just start by writing out Pascal's number first. Now, setting this up hopefully should be pretty simple by now. We take that first term, 3x squared, and we raise it to the highest power possible. And then we're going to take the second term, negative 8, and raise it to the lowest power possible. Now, you probably know how to fill the rest of these in. I'm going to do these as fast as I can. You're welcome to pause the video and try and see how fast you can do it as well. So here we go. We start dropping the exponents down. You can race me if you want. I don't think you'll beat me. Well, maybe you will. As I'm doing this, I realized I could have just paused the video and then had it magically show up on the screen for you. Sorry for wasting your time. All right, so these are the 6 terms that we're going to have for this particular binomial expansion. So setting it up is not the difficult part. However, simplifying it, that's usually where we tend to struggle and make a couple more mistakes. So let's go ahead and simplify this. We have 1, that's a 1, and negative 8 to the 0, that's also a 1. So those are pretty easy to deal with, just becomes 1. But this is where it gets a little more difficult. We have 3x squared raised to the fifth power. So let me just illustrate what that means. 3x squared means 3 times x times x. And that has to get raised, so it's multiplying by itself 5 times. So times 3x squared, another 3x squared, times another 3x squared, and one more, 3x squared. Now, you certainly don't have to show all of this work as you're going through. I'm just doing it to show you what's going on. So we have 3 times 3 times 3 times 3 times 3. That's just 3 to the fifth power, which is 243. And you'll notice we have x squared. There's 2 of them, 2 of them, 2 of them, 2 of them, 2 of them. It's raised to the fifth power, so you can take that 2 times 5, and it becomes x to the 10th. So let me again just show you what we just did here. When we have 3x squared to the fifth, you're taking 3 and raising it to the fifth. That's 243. And this x squared to the fifth power, when you have a power raised to another power, you can just multiply the exponents. So 2 times 5 gives you 10. So that first term would be 243 x to the 10th power. Let's go ahead to the next one. We have 5. I'm just going to start by writing the 5. Then we have 3x squared raised to the fourth power. So that 3 gets raised to the fourth power, and that's an 81. And that x squared gets raised to the fourth power, and that's going to become x to the 8th power. And then we have negative 8 to the first. That's just a negative 8. So then what we're going to do is we're going to probably take a calculator out, and we can do 5 times 81 and multiply it by negative 8. And it gives us the coefficient, and that's going to be a negative 3,240, and it's going to be x to the 8th power. So there's your second term in the binomial expansion. We're going to move down to the third one. We have 10 is what we're starting with. Then we have 3x squared raised to the third power. So we take 3 times 3 times 3, and that's going to give us 27. And x squared to the third power gives us x to the 6th. And then we take negative 8 and square it. That gives us a positive 64. So on your calculator, you can do 10 times 27, that's 270. and then multiply it by 64. And that gives us 17,280, and it's going to be x to the 6th power. Hopefully, you're noticing some patterns that go on here. The exponents go from 10 to 8 to 6. I bet you can probably figure out what the next one's going to be. It's also alternating between a positive, a negative, positive, so I bet you can figure out what the next one's going to be. And let's find that next one. So we start with the 10. Then we're taking 3x squared and we're squaring it, so that's going to be 9x to the 4th power. And if we take 8 times 8 times 8, that gives us a 512. So this would become a negative 512. And now we can multiply them all together. So we take 10 times 9 is 90. Multiply that by negative 512, and that gives you a negative 46,080. And it's x to the 4th power. Okay. 2 left. We start with our Pascal number, that's a 5. 3x squared to the 1st power, that's just 3x squared. And then we have negative 8 to the 4th. So I think of that as negative 8 squared, that's 64. And then I square that, so it's just 64 times 64, which obviously is 4,096. And then what we can do is we can take the 5 times 3, that's 15, multiply it by the 4,096, and that gives us 61,440, and it is x squared. And we get to our last one, and we have 1 times 1 is just 1. So we can take 8 times 8 times 8 times 8 times 8, and that's going to give us the negative 8 to the 5th, which is negative 32,768. So your final answer would normally be written horizontally going across. In the interest of time, I'm just going to circle this right here. This is your final expanded polynomial. And go ahead and try the last one on your own, do the quick check, and then you are done for the week. See you next week, where we learn a little bit more about binomial expansion.